Hello everyone. In this lecture, I want to talk about the logistic regression analysis. The purpose of this analysis is to predict the probability of getting a value for the dependent variable. Here we have two important keywords, probability and dependent variable value. We want to use this analysis to calculate how likely to get a value for the dependent variable. I want to use an example to show everyone how to use this analysis. Joe wants to sell virtual goals in his fitness mobile app, but he's not very sure if users would pay for the virtual goals. By the way, in-app sales is a very popular business model for mobile development. You want to offer the app for free to the user, get them interested, addicted, and then you can start selling the virtual goals, such as the new challenging levels in a mobile game, additional information for a mobile app, virtual clothes, virtual properties for the characters in the mobile app, and so on. This is a very popular business model in practice. But Joe is not very sure if users would pay for the virtual goals. So we want to find out the probability for a user to buy virtual goals in the mobile app. As we discussed in the previous lecture, Joe could have a 2 million user population. It's impossible for him to study the entire population. That's why we drew a sample of 100 users. We asked each one of them, would you pay for the virtual goals if we offer such an option? Each one of the customers would give us a yes or no answer. So currently in our data set, we have 100 yes or no answers. We want to use this sample to build a model in order to predict if a customer from the population would buy the virtual goals or not. Joe wants to answer the following two questions. First, if a user's usage hours would influence whether she would buy the virtual goals in the mobile app. Second, if a user's yearly incomes and gym visits can influence whether she would pay for the virtual goals in the mobile app. We want to build a model and interpret the analysis result. Before we answer these two questions, I have a question for everyone. Let's use the first question as an example. In the first question, which factor should be the dependent variable? Which factor should be the independent variable? Let me give everybody about 30 seconds to think about this question. Which one is the dependent? Which one is the independent in the first question? As we learned in the previous lecture, the dependent variable is the factor that is being influenced by others. The independent factor is the variable that influences others. So obviously, how long the user is using the mobile app is the independent variable. Whether the user would pay for the virtual goals is the dependent variable. I have another question. Do we need to predict the value for the dependent variable, or we want to predict the likelihood of getting yes or no for the dependent variable? Think about this question for 30 seconds. For the dependent variable, we really don't need to predict the value for it, right? Because we already know the possible value for the dependent variable, either a yes or a no. What we don't know is the likelihood for us to get a yes or a no for a user, right? That's why the dependent variable in the first question should be the probability of getting either a yes or a no for a customer's willingness to pay for the virtual goods. So how can we predict the likelihood for a customer to pay for the virtual goods? We need to use a new model called the Logistic Regression to predict this probability. I want to show everyone how to use this analysis in the R software. Before we perform this analysis, please download the source data fitness app log.csv file into your working directory. Next, in the R software, we want to build the data frame. Let's call this fitness log. And then we want to use the read.table function to bring in the source data. The source data file is called fitness app log.csv. The separator is a comma. Header equals to true. Now let's take a look at the main structure of the fitness log. We want to use the head function. So in this case, as you can see, different from the previous source data file, we have a pay or not vector now. For each customer, we ask them if he or she would pay for the virtual goods, and then this customer will give us a yes or no answer. We record all these answers in this data set. Currently, we have 100 responses because the head function can only give us the few data records at the beginning of the source data. That's why you can only see 6 data records here. But actually, we have 100 responses in this data set. If you want to see them all, you can type in fitness log directly, and then you will see the entire data set. Now I want to use the logistic regression analysis to predict the likelihood for us to get either a yes or a no for a customer in the pay or not question. First, I want to build a variable to hold the analysis result. Let's call this log analysis. Log represents logistic. And then I want to build the model. The function name for logistic regression in R is GLM. This is different from linear regression analysis. And then parentheses. In GLM function, we need to specify 3 parameters. First, the model we want to build. What we want to build is we want to predict the likelihood for a customer to get either a yes or no for the pay or not question. So pay or not is the dependent variable here. And then a tilde sign. Next to the tilde sign, we want to type in the independent variable name. In our case, we want to use how long the user will be using the mobile app to predict the likelihood of payment. So let's type in the independent variable name, which is hours here, and then a comma. The second parameter in the logistic regression is the source data frame name. Let's type in data equals to fitness log. This is where we saved the source data, right? Fitness log. The first 2 parameters are very similar to the linear analysis we did in the previous lecture. The only difference is For logistic regression, we have to specify the third parameter. It's called a family. Family equals to binomial. Why binomial? Because in the pay or not column, we only have either a yes or a no answer. So that's why we have the binomial values for pay or not vector. Binomial and then parentheses. Then we want to type in link equals to two double quotes and then type in logit. Logit represents logistic. What this means is we want to use the logistic regression analysis model to predict the likelihood of getting either a yes or a no to the pay or not question. And then we want to press enter. Now we get the answer. If you want to see the answer, just type in summary and then type in the variable name, log analysis. This variable holds the analysis result. Press enter, you will see the result. I already copied the screen capture into the PowerPoint. So let's go back to the PowerPoint and then take a look at the result. The equation to calculate the probability for us to get a yes answer to the pay or not question is listed on this slide. PR in this case represents probability. This is how we calculate the probability for us to get a yes answer. This probability equals to 1 over 1 plus e with power of negative y. In this equation, we already know all values except for y. We already know e. E in mathematics equals to about 2.79, right? This is a constant value. What we don't know though is the y value. How can we calculate y? When we calculate y, we have to use the reports from the analysis result. According to the estimate in the result, we can build the equation to calculate y value. According to the current result, y equals to negative 10.41 plus 1.32, I round the number, 1.32 times hours. This is how we calculate y. When we get the y value, we want to bring it back to the probability calculation. And then we can get the probability for us to get a yes answer from a customer to the pay or not question. Let's see an example. Let's say we have a customer. She uses mobile app for 10 hours a week. According to the y equation, we want to replace hours factor with 10, and then we can get y equals to 2.79. Now we get the y value, so we bring 2.79 back to the probability calculation, and then we can get the probability for this customer to say yes is 94.2%. This is how we calculate the probability to get a yes answer. What about the probability to get a no answer? We only need to use 1 minus the probability of yes. That will be the probability of no. In this case, 1 minus 94.2%. That would be 5.8%. This is how we calculate the probabilities. At the beginning of this lecture, I told everyone that we are interested in the probability for the population. In the future, we want to draw any one customer from the population and see what is the probability for her to say yes or no. How can we get this answer? We still need to look at which value? The p-value. We want to compare the p-value to the level of significance. If p is less than the level of significance, then we can make the conclusion that the current model from the sample can be applied to the population. So let's take a look at the p-value. The p-value for hours is 3.88 times e with the power of -7. This is actually a very small number. As you can see, next to this number, we have 3 stars, right? If you look at the statement at the end of this report, 3 stars means this value, 3.88 times e with the power of -7, is between 0 and 0.001. This number is very close to value 0. It is much smaller than the level of significance standards, such as 0.05 or 0.01. Now we can make the conclusion that the model we built according to the sample can be applied to the population. In the future, the mobile developer can randomly choose a customer from the 2 million population. Ask this customer how long she or he would use the mobile app. Plug in the hours number into the y equation, and then bring the y value back to the probability. Then he is able to calculate the probability for this customer to say yes to the pay or not question. This is how we use the logistic regression to predict the probability of getting a yes or no answer to the dependent variable. Let's use the same principle to answer question number 2. Joe wants to know if a user's yearly incomes and gym visits can influence whether she would buy the virtual goods in the mobile app. Let's go to our software. We need to build a variable to hold the result. Let's call this log analysis 2. This means this is the answer for question number 2. And then we want to type in the logistic analysis function name. What is it? It should be GLM, right? We need to specify 3 parameters. First, the model. In our case, the dependent variable is still pay or not, and then a tilde sign. In this case, we want to use 2 independent variables, right? Incomes plus gym visits. This is how you use 2 or more independent variables in the logistic regression analysis. You use the plus sign to connect each independent variable. And then the second parameter should be source data frame. It equals to fitness log. And then the third parameter should be family. Family equals to binomial. And then parentheses. Inside of the inner parentheses, we want to type in link equals to 2 double quotes and then logistic. Press enter. Now we get the result. We can take a look at the result. Summary log analysis 2. I already get the screen capture, so let's go back to the PowerPoint. The way of calculating the probability of getting a yes answer is the same. It equals to 1 over 1 plus e with the power of -y. But the way of calculating y is different now. We have to look at the report from the analysis result. Y equals to -11.45 plus 0.09, I round the number to 0.09, times incomes plus 0.99 times gym visits. This is how you calculate y value for this case. After you get a customer, you want to ask this customer 2 questions. How much do you make every year? How many times you visit gyms every week? So when she gives you 2 answers, you can plug in those numbers into the y equation. Let's say a customer can make $90,000 a year. She goes to gym 5 times a week. We replace incomes with 90. We replace gym visits with the value 5. And then we get the y value equals to 1.6. After you get this value, you want to bring it back to the probability calculation, and then you can get the result. Some classmates may have a question about the probability calculation. How can we calculate this value, probability, in the R software? Notice that in R, E is represented by EXP. So let's take a look at this example in R. Now I already get the value for y is 1.6, right? Now I want to calculate the probability. So I want to type in 1 over parentheses 1 plus EXP, another set of parentheses. In the inner parentheses, I want to type in negative y value, right? Y in this case equals to 1.6. So negative 1.6 is the value I want to type in. Negative 1.6. This is the probability for us to get a yes answer from this customer.